Hey guys, welcome to Unit 7, Lesson 2. Today's topic is trig values at a given point. So I want you to pause the video and try the warm-up. The warm-up number 1. In the accompanying diagram of right triangle ABC, what is the measure of angle A correct to the nearest tenth of a degree? So again, whenever it tells me to round, I always like to underline and I put a placeholder. So I know it's going to be rounded to one decimal place. So it's telling me find the measure of angle A. And all the sides ratios are given. A is actually here. I would erase that from here. So what do? We know our SOHCAHTOA. SOHCAHTOA. In the last lesson we learned if you were given two sides how you could find the third side and the remaining 6 ratios. Here we're already given the 3 sides but we want to find the angle. So how do we do that? So I can pick any 2 sides. I'm going to pick, let's say, this is the opposite in reference to angle A. This is the opposite. This is 90 degrees, so my 25 will be my hypotenuse. Right? So I'm going to use these 2 numbers. So what's opposite of our hypotenuse? That is my sine ratio. So sine of A, I don't know the angle right now, is equal to its opposite over hypotenuse. So 24 over 25. Now how do I solve for A? On your calculator there's a function. If you do, I'm just going to write it here, second, that's your key, that's one key, I'm just going to make it in a box, second sine. Make sure your mode is in degrees, so I'm just going to put an asterisk here, mode is in degrees. So so do that second sine and type in, it will give you sine inverse. So you find A by doing sine inverse. You did sine inverse on both sides, right? This cancels this, but you're left on the right side is sine inverse of 24 over 25. So how are you going to put that in the calculator? Do second sine and then type in 24 over 25. And that would give you an answer of angle A, which is 73, rounded to the nearest tenth, 73.7 degrees. So that's how you find the angle. You do second sine or second cosine, whatever your function is, or second tangent. That's how you do it. Okay, it says determine the quadrant in which the following angle lies. Again, let's quickly review our quadrants. You always go in counterclockwise direction. You start with the top left, top right. 1, 2, 3, 4. These are your quadrants. That's how they go. It is in counterclockwise direction, right? Your angles are positive when you go in counterclockwise direction, and they're negative if you go in this direction. So these are a few things that you need to remember from the past. And we also know when we're converting from degrees, this is in radians, right? You want to convert it to degrees. So what are we going to do? We're going to multiply by 180 over pi. So the pi's cancel out. And what are you left with? If you simplify it, you're left with, you can either do mental math. 15 goes into 180. 12 times 8 is 96. Or just multiply 8 times 180 divided by 15. So this is 96 degrees. So 96 degrees is, I'm going to do the angle. This is 0, 90. I should pick a different color. 180, 270, and then 360, and so on, 450, and so on. So where is 96 degrees? 96 degrees is in the second quadrant. It's more than 90, less than 180, so it is in the second quadrant. I'm going to draw the quadrants here again, and I'm going to do the negative angles this time. So it's 0. If I'm going in clockwise direction, this will be negative 90, negative 180, negative 270, and negative 360, right? So basically negative 270 and positive 90 are the same. Similarly, negative 90 and positive 270 degrees are the same. Negative 180 and positive 180 are the same, right? So these are a few things that we need to keep in mind. Again, when you're given an angle in radians, convert it to degrees. Either you can multiply by, what would we say, 180 over pi, or I'm going to actually zoom in here so that we can do it better, or just substitute pi with 180, because think about it, the pi's cancel out, so if either you can substitute it with 180 over 10 or negative 3 pi over 10 times 180 over pi. No matter which way you do, you'll get the same answer. Let's simplify this one. This is just 0. So 18 times 3 is negative 54. So let's see if we get the same thing here. The zeros cancel out. 18 times 3 is negative 54. So no matter which way you do it, you'll end up with the same answer. Okay, so let's put this negative 54. Negative 54 is in the fourth quadrant. It's somewhere. So before I start the example 1, I actually wanted to quickly review again your standard position, standard position, reference triangles, and all that. Your angle is in standard position. If I was to take my axis, this is my axis, and my angle is in standard position if my initial ray is fixed to like the x-axis and my terminal ray could be anywhere, depending on what the angle is. It could be on the quadrant, it could be anywhere. Just start sketching the terminal ray as a dotted line. So basically, this is what your angle looks like, right? This is your initial. So your initial is glued to the x-axis, and your terminal ray is where will tell you how big the angle is, right? So the angle is, we usually use a Greek letter theta to denote an angle. So now when we are working with the reference triangles, remember your reference triangles are between the terminal ray and the x-axis. The angle formed by the terminal ray, that's your reference angle. And if I was to drop a perpendicular, that becomes a reference triangle. So in each quadrant, it is the terminal ray and the x-axis, and that's your angle theta. And these are right triangles. Same thing here. So this is what your reference triangle would look like. One of each, depending on which quadrant you're in. I'm going to also draw, it looks like more like a butterfly, right? It will never look like an hourglass. Your triangles will not look like an hourglass. So be very careful, guys, when you're drawing these reference triangles. So now, since we know about our reference triangle, we know about what an angle is in standard position, let's get started with the question. I changed the question a little. It says, let negative 512 be a point on the terminal side of an angle in standard position. Find all the values. I would say find the value of 6 trig functions. So I want to find the value of all 6 trig functions. So first thing to do is to sketch this point. If I was to, I always like to draw pictures. If I was to take this point, negative 512 will be a point something like this, right? This would be 5 and this would be, it's like a little higher, 12, all right? So negative 5 actually. But since we're working, so what do? Is we draw a reference triangle. And a reference triangle, I said it will look like one of the wings of a butterfly, right? So this is, you dropped a perpendicular, so this is 90 and this is your angle theta. So do you agree that this distance is 5 units? So this is 5, and I'm going to do it in a different color. And the vertical distance is 12 units, right? So now, how do I find the remaining trig functions? I know SOHCAHTOA. I'm going to use SOHCAHTOA. It's very similar to what we did for lesson 1. So now, I already know my 2 sides of a right triangle. Can I find the third one? Yes. So the first thing you'll always do is, so this is the first thing. Draw a picture, sketch your reference triangle. Second, you want to use the Pythagorean theorem, which is a square plus b square equals c square, and find the missing side. So here, your missing side is the hypotenuse. It's across from, your hypotenuse is always across from the right angle. And it's the longest side of the right triangle. So I'm going to substitute in 5 square plus 12 square equals c square. This would be what? 25 plus 144 is 169 equals c squared. Take the square root, and c is equal to 13. Again, we take the positive value only because we're talking about lengths of a triangle. So this is going to be 13. I'm going to take a different color. So this is 13. So you know three sides of your triangle, all the three sides. So now you can write the ratios. So let's start with sine. So sine of theta will be what? Sine is opposite over hypotenuse. So what's my opposite? It is in reference to your angle theta, and your angle theta is between the x-axis and the terminal ray. You cannot pick this to be theta, so please don't do that, okay? So it's that. So its opposite is 12 over 13. Then I'm just going to write out all the functions: cosine, tangent, and then the reciprocal functions are sine is cosecant theta, and then it is secant theta, and then the last one is cotangent theta. So now let's write down the ratio. I also wanted to actually discuss the signs. I don't know if you remember it from Algebra 2. We'll quickly do this. A, S, T, C. What does that stand for? A means all trig functions are positive in the first quadrant. S stands for, I'm going to actually do a different color. I'm going to do black. So that's sine, and it's reciprocal, which is cosecant. We write it as CSC, are positive in the second quadrant. Tangent and its reciprocal are positive in the third quadrant, and cosine or secant are positive in the fourth quadrant. So since we're in the second quadrant, my sine will be positive and my cosecant will be positive. The rest, everything will be negative. Okay, so be very careful. The signs are very important. So now the ratio for cosine is adjacent over hypotenuse, which is what? 5 over 13. Tangent. So tangent is opposite over adjacent. So my opposite in respect to theta is 12 over adjacent is 5, and it's going to be negative because we're in the second quadrant. Now once you have all the sine, cosine, tangent, finding the other three is very easy. It is just flipping the fraction. So this would be, cosecant would be what? 13 over 12. Secant would be negative 13 over 5, and cotangent would be negative 5 over 12. So this is how you find the ratios for all the 6 trig functions. Once you know the 3, you can find the other. Again, the whole idea is to know how your reference triangle and use the Pythagorean theorem to find the third side. So good luck, finish up the lesson, guys, and if you have any questions, reach out to your teacher.